Okay, this is a lesson on molarity. Now, molarity is also a kind of concentration, all right? So, and when I talk about concentration, I'm talking about if something's dilute or something's concentrated, not whether it's strong or weak. That's a completely different lecture. So here we have molar concentration. Notice the definition of this one. It's the number of moles of a solute in liter of solution. So where molality was moles of solute and kilogram of solution, molarity is moles of solute and liter of solution. Molarity is actually used more than molality. I don't know if you've noticed on solutions that I've brought out, sometimes I'll have a capital M beside them. That's because molarity is abbreviated with a capital M or sometimes in brackets. Like sometimes you might see, like if I give you A in brackets, if A was a compound, that would mean the molarity of compound A, if I ever put brackets with it. So you can see it with, but usually it's given with a capital M, especially if it has numbers with it. So here's the formula. Molarity, here's the formula in words. Molarity is moles per liter. It's the amount of solute moles divided by the volume of solution in liters. It is important that you make sure that that's in liters, not in milliliters. A lot of times when we measure it, it'll be measured in milliliters, and then you have to convert it. Here's the formula. Capital M stands for molarity, moles per liter. That equals moles of solute and liters of solution. And again, molarity is affected by temperature because temperature affects volume. Remember, if you change the temperature, you can expand or contract things, right? So in that case, this will not, you wouldn't use molarity if you're going to be changing temperature, like in freezing point and boiling point, things like that. All right. Again, just to review, and is that if you're doing a solution, remember the solute is the substance that gets dissolved, and the solvent is the substance that it dissolves in. But notice that this is different because this is in liters of solution. So that means the total solution, solvent and solute included together. So this is a little bit different in that point from molarity also. So this will be the moles of solute in the total solution. Because keep in mind, if I had, let's say I have 10 grams of sugar and dissolve it in, let's say 500 milliliters of water, when I add the sugar to the water, it's probably going to add a small amount of volume to that also. So now the volume of the entire solution is different. So when we're doing molarity, we're doing the entire solution, not just the solvent. That's important. Okay, let me go on to the next page. Here's a sample problem. Okay, here you have a saline solution, contains 0.90 grams of sodium chloride, NaCl, dissolved in 100 milliliters of solution. What is the molarity of the solution? Now notice that this does say solution, not solvent. All right, pretty easy. All right, we know that the molarity is moles over volume. Right? Everybody agree with that? So, and the moles have to be the moles of the solute. This has to be for solute. Okay? So, this is a solute. Does everybody agree with that? Good job. That's a solute. And this is the solution. That's pretty easy to tell. I'm going to use that abbreviation for solution. That's not official, but it's pretty easy to tell because it says 100 milliliters of solution.
So D is solution?
V stands for volume, but it is the volume of the solution. Ooh, that's going to be an O. All right? So now, whenever we do this, you have to remember this got to be moles, this got to be in liters. So I'm going to start with my moles of solute. Do I have that? No. I do not have moles of solute, but I can change it to moles of solute, right? I'm going to do the same thing right here. I'm going to take this grams and change to moles. So I'm going to say 0.90 grams of NaCl. I'm going to look up the mass of NaCl on the periodic table. That's 58.5. So that'd be 58.5 grams per mole. And then I'm going to do that math. And that comes out to be 0.90 divided by 58.5. And that gives me 0.015 moles of NaCl.
What's the solvent?
Pardon me?
Solution.
solution. That's just my abbreviation for solution. Okay? Now, so what we're going to do now is, I now have the number that can go right there. Everybody agree with that? Okay. Now what I need to do is I have my volume of solution. Well, look right here. That's given to me. The problem is that it's given to me in milliliters, though. I want it in liters, right? So to change that to liters, I'm going to move this decimal back 3 places, and that becomes 0.1000 liters. Everybody agree with that?
What was it originally?
It originally was 100. It was 100.0, and I'm moving the decimal back 3 places, or dividing by 1,000 is what I'm doing. So now I can put it to my problem. Molarity equals 0.015 moles of NaCl divided by 0.1000 liters of solution. All right? 0.015 divided by 0.1000 equals 0.15 capital M, or I can say 0.15 moles per liter. Does that make sense? That should be, yes it is. Because look right here, this has 2 significant digits, that has 4 significant digits. I can keep the least number, which is 2. All right? Any questions on that one? All right, so let's go to example problem number 2. All right, this time we have at 20 centimeters degrees, start again, at 20 degrees Celsius, a saturated solution of calcium sulfate, CaSO4, has a concentration of 0.0153 moles per liter. That's the same thing as molarity. A student takes 65 milliliters of solution and evaporates it. What mass in grams is left in the evaporating dish? So what I'm going to do is, this is kind of a backwards one, right? I already have my molarity. This is capital M right there. Okay? That's capital M. I'm looking for grams. I have my volume of solution. Okay? That's what I'm given in the problem. So if I go by the formula, molarity equals moles of solute divided by liters of solution. All right? I have this number right here. I have molarity, so I can put in for that 0.0153 capital M, or moles per liter, equals, do I have my moles of solute? No, I don't have that. So I'm going to put an X for that. My liters of solution, do I have that? That's 0.065, because I have to move it back 3 places. So it was 65 milliliters, right? So if this is 65 milliliters, I'm going to move that decimal back 3 places, and it's going to become 0.065 liters. Mathematically, what am I going to do now? Multiply both sides by 0.065. So 0.0153 times 0.065 equals 0.0009945, if you want to carry it that far. Or you could have written that in scientific notation. A lot of your calculators will give that to you in scientific notation. Okay? Liters canceled out, that gives you moles, equals X. All right? Now, I'm not going to want to use that big number probably because of significant digits. Okay? But I now have my X. Can I now find grams? Yes, I can find my grams. So let me extend this page just a little bit. So now I'm going to put that 0.00099, I'm going to round that to 5, moles of my solution. And that was 50. I already forgot what my compound was. What was my compound? CaSO4, thank you. So this is moles of CaSO4. And so what I'm going to do is I'm going to look up calcium. Calcium's 40. Sulfur's 32. Oxygen 16 times 4 is 64. and that's going to give us 136. And I'm going to put my 136 on top because I want moles to cancel out right there. So I'll now say that number times 136. And I got 0.135 grams of calcium sulfate. Does that make sense? Now, let's check. 3 significant digits, 2 significant digits. Is this the right answer?
No.
Not significant digit wise, because I can only keep 2 significant digits. I have to go by the least. So my answer is 0.14 grams of calcium sulfate. And that's problem number 2.